Hello students, in the previous lecture I have explained you Kirchhoff'S law. With the help of Kirchhoff'S law, how will you simplify any electrical circuit? Analyze any electrical circuit. Means how will you determine the electric current and potential difference through various resistors in that electrical circuit. It's clear? Now today, so I have explained two laws. Kirchhoff's current law and Kirchhoff's voltage law. What is the Kirchhoff's current law? So as you know that at any junction of an electrical network, sum of incoming currents is equal to the sum of outgoing currents. Now according to the Kirchhoff's voltage law, we will apply it in this form. Sigma IR equals to sigma I. And it will be applied in any loop, in any closed loop. So we will select some direction of traversing in that loop. That direction will be arbitrary, totally upon you. You may select clockwise or you may select anti-clockwise. Any direction you can select. So if the direction across which you are traveling is in the direction of current through any resistor, then the I into R across that resistor will be taken positive. Otherwise it will be taken negative. Means if you are traversing opposite to the direction of current through that resistor, then I into R will be taken negative. Similarly for the EMF, if you are crossing to any cell from positive terminal to the negative terminal, EMF will be taken negative, and from negative to positive it will be taken positive. So now you can see here, that day I told that in the questions which I explained that day, if you have not watched the video, then you watch that video. So I will explain that there will be current in various branches are given and you have to determine. Suppose if the current is not mentioned in any circuit, then how will you do? So today I will tell you this by taking a single current. And this question has been asked in 2019 CBSE examination. In one set this question was asked. So see here this is the setup and you have to determine the current through 40 ohm and 20 ohm. Though here there are two cells, but we will not take two current, we will take only one current. Suppose since it is a bigger voltage, so suppose the current which comes out from here is I. It's clear? When here also current will be I, when it will be reached at point C, what will be, some current will flow through this. Suppose the current which is flowing through I1 is 40 ohm is I1. So the remaining current, what will be the remaining current? I minus I1. It will flow through this. I minus I1 will flow through this. It's clear? And here I minus I1 current is coming from that side. When both will meet here, what will happen? The current will once again become I. It's clear? So we have taken a single current. It's clear? With the help of single current, we will do this question. Now see here. So in the same way, we will apply Kirchhoff's voltage law. So we have taken one loop and we will name the loop in the same way as we are traversing. So in loop, here you can take A, B, C, D, A from Kirchhoff's voltage law. Here we are traversing from where to where? From A to B, then B to C, then C to D, and then D to E. It's clear? We will apply the Kirchhoff's voltage law in that form. IR you will get here as well as here. When you are going in this way, you are traveling in the direction of current, so I into R will be positive. What is I here? I is I, R is 20, so it will be with positive side 20I. Then when you go through this here also, you go in the same direction, in the direction of current. In the direction of current, therefore what will be IR? I is I1, R is 40, so with positive sign 40I1. It will be equal to, there is no other IR, Now this is the source of EMF that you are crossing in what way? From negative to positive. Negative to positive means EMF will be taken positive. So this equation you can cancel by 20. So it will be I plus 2I1 equals to 4. This is the equation 1. It's clear. Then in loop, you take another loop. I have taken A, B, E, F, A. Loop A, B, F, A from Kirchhoff's voltage law. So you can see here you are traveling in what direction? In the direction of current. Here you are also traveling in the direction of current. So IR here it will be positive. What will be IR? 20 into I plus here it will be 10 I minus I1 equals to, if you see here you are crossing to this cell from negative to positive, and then here also you are crossing negative to positive. So EMF at both the places you will take with plus sign. So 80 plus 40. When you will simplify, it will be 30I minus 10I1 equals to 120. On further simplifying, on cancelling by 10, you will get 3I minus I1 equals to 12. This is one equation. Another equation is I plus 2I1 equals to 4. So what will you do? You multiply this whole by 2 and add. So on adding 2 3 are 6I plus 1I, that is 7I. Minus 2I1 plus 2I1 will be cancelled, equals to 24 plus 4 equals to 28. 28, so I equals to what? I equals to 4 ampere. 4 ampere means the current through 2 ohm. Current through 2 ohm. This is equals to 4 ampere. Then you can see here what will be the current through this. So you have to find I1. You substitute here in any one equation. Here I am substituting. When you will substitute here, this is I is given 4 plus 4 plus 2I1 equals to 4. 4 plus 2I1 equals to 4 because I is this equals to 4. So from here you will get I1 equals to 0. So what is the current through 10 ohm? Current through 10 ohm, it will be equal to I minus I1. What is I here? 4. I1 is 0, that is equals to 4 ampere. It's clear? It will be equal to 4 ampere. It's clear? So this way you can do. Now then one more question that is also asked in the 2019 CBSE examination, but in the other set. It's clear? As you know that there are number of sets in the CBSE examination. So this also we will do by the Kirchhoff's law. Now see here. Here this is question number. This is 8 volt 2 ohm. This is 6 volt 1 ohm. And this is 4. Now you have to find the potential difference across 4 ohm. Potential difference across 4 ohm. That you have to find. It's clear? So how will you do this? So that I explained by taking single current. Here I am taking current I1 from here and I2 from here. It's clear? One more thing that I have told. If the value of current comes out negative, it means the actual direction of current through that resistor, through that cell will be opposite to marked in the circuit diagram. It's clear? So that you will remember. Now here this I1 current comes from this side, I2 from this cell. So what will be the current here? I1 plus I2. It's clear? Here you have taken this loop A, B, C, D, E, F. It's clear? Now you apply the Kirchhoff's voltage law. So see here, first you take this loop BADC, loop BADCA from Kirchhoff's voltage law. When you will apply here, you are moving in the direction of current, that is here. What is current? Here I1, therefore here also I1. So it will be 2I1. It's clear? But here you go opposite to the current because you are traveling in this way. It's clear? So here current direction is this and you are going opposite. What is IR? I is I2, R is 1. So it will be 1I2 but with negative sign. Equals to sigma I. So cell is crossed negative to positive, so it is plus it, and it is positive to negative, so minus 6. So one equation will be 2I1 minus I2 equals to 2. It's clear? Then you take loop CDFE. Loop CDFEC. If you see here in the direction of current, so IR will be positive, 1 into I2. Then here also the IR will be positive because you are traveling this way. So IR will be positive, that is 4 I1 plus 4 I2. It's clear? Equals to, cell is being crossed in what way? Negative to the positive, that is equals to 6. So it is equals to 4I1 plus 5I2 equals to 6. This is equation 2. Now you have to simplify this, solve this. So how will you solve it? You write down this 2I1 minus I2 equals to 2. You multiply this whole equation by 2 and then subtract. So when you will subtract, sign will be changed. It's clear? Here 2 2s are 4I1, 4I1 cancel. This is 2I2 plus 5I2, that is 7I2 equals to 6 minus 4, that is equals to 2. So I2 equals to 2 upon 7 ampere. Then you place here. So what will be 2I1? This equation is 2I1 minus I2 equals to 2. Minus I2 2 upon 7 equals to 2. So 2I1 equals to 2 plus 2 upon 7. That is equals to 14 to 16 upon 7. So I1 equals to 8 upon 7 ampere. So what is the current through this 4 ohm? It is I1 plus I2. Current through 4 ohm is I1 plus I2. So current through 4 ohm. This is I1 plus I2. I1 plus I2 equals to how much? You calculated. I1 is how much? You have calculated here somewhere this I1. This is I1. It's clear. 8 upon 7. I2 is 2 upon 7. That is 10 upon 7. Here. Current is this. So what is potential difference? Potential difference across 4 ohm. So potential difference I into R. I you have calculated 10 upon 7. R is 4, that is equals to 40 upon 7 volt. 40 upon 7 volt. So this way you will do. It's clear? Now see here, after this, I will tell you some more questions, but that I will not solve. So only you can note down that question. It's clear. Now see here, this is from some other book. And that you will try to solve by your rule. And after that, I will take one more topic, Wheatstone bridge. What is Wheatstone bridge? It is the combination of registers which is used to determine some unknown register. It's clear. And how will you determine? So see here this question. Here it is given. That you can note. This is 1111, 1 ohm, 1 ohm, 1 ohm, 2 ohm. Then this is 2111, 2 ohm, 1 ohm, 1 ohm. And this is 5. And here it is a battery whose internal resistance is negligible and EMF is given 3.7 volt. 3.7 volt. This. Now in this question you have to determine the current through 5 ohm resistance and equivalent resistance between A and B. Number 1, you have to find the current through 5 ohm resistance. Current through 5 ohm. Through 5 ohm. This and equivalent resistance in between A and B. See here, how will you determine the equivalent resistance between A and B? First you will find the total current, the current which is here, the current which is here at this point. So total current is known, voltage is known, so R equals to V upon I. That way you will find total current you find here. It's clear? And then V upon I will be the resistance. That also you will do by the Kirchhoff'S law.